Welcome back, guys. Moving on with quadratic equations, we have to solve for the length of each uniform strip or deck in both of these scenarios here. So it's like two separate questions. And these types of questions are very popular. They're very similar, just the way we draw the diagrams is going to be a little bit different. That's why I wanted to present both, just so you can be ready for whatever they throw at you. So scenario one, we have a lawn measures 20 meters by 15 meters, and you mow a uniform strip around the edge that leaves an area which is 42% of the original area. So let's draw a diagram here. So we have a lawn that is 20 meters by 15 meters. So this is 15 meters as well. This is 20 meters. And what's happening is you are going to mow a uniform strip all along the edge. Like that. So because this strip has a uniform width, let's call the width x here. So this here is a width of x, which means this here is a width of x. This here is a width of x, and that there is a width of x as well. So notice here how we can create expressions for this length and this width over here, because this rectangle that's left in the middle, that is the patch of grass that is left. And then the 20 by 15 was the original patch of grass. So the original patch of grass has a length of 20. So what's this length going to be here? Well, it's going to be 20 minus x minus x. Right? Because this length is not going to be there anymore, and this length is not going to be there anymore. So we got to subtract those two x's there. So it's like 20 minus 2x. That's an expression for the length of the patch of grass that is left. Now, what about the width here? Well, the original patch of grass had a width of 15. So that means the patch of grass that's left, the width of it, is going to be 15 minus 2x. There's two x's there that we have to subtract. I can actually write it a little further down. All right, does that make sense? 15 minus x minus x. That is the expression for the width for the patch of grass that is left. Okay? So what we're solving for is the length of the uniform strip, right? The strip that was mowed down, the grass that was mowed down. So we're told that the area that's left here is 42% of the original area. So the original area is what? It's 20 by 15, which is 300 meters squared. So the new area, the area that's left here in the middle, is 42% of 300 meters squared. So we would take 300 meters squared, multiply it by 0.42. And that would give us 126 meters squared. So this area over here is 126 meters squared. So notice now that we could solve for x, because we know the length of this times the width of it has to equal 126. So that means 20 minus 2x, the expression for the length, times 15 minus 2x, the expression for the width, has to equal 126. And now this is just a quadratic equation. We would just expand this bracket, so let's FOIL it out. So 20 times 15 gives us 300. 20 times negative 2x is minus 40x. This is negative 30x. And that is 4x squared. That's equal to 126. Let's bring the 126 over. So the 4x squared would go in front. These two are like terms, so that would be minus 70x. And then 300 minus 126, that gives us positive 174. And that has to equal 0. And then from here, let's try to factor this. You could throw this in the quadratic formula if you want. I'm going to actually factor it. So I'll have, let's take out a 2. So we'll have 2x squared minus 35x plus 87. That's going to equal 0. So rewriting that up here, we now have to factor this 2x squared minus 35x plus 87. So I'm going to do that down here. So what do we do? 2 times 87 gives us 174. And then the b value is negative 35. So what two numbers multiply to 174 add up to negative 35? Negative 29, negative 6, negative 29, negative 6. So we take this here, 2x squared minus 6x minus 29x plus 87. So we took the negative 35x, decomposed it to negative 6x minus 29x. Then from here, we could take out a 2x from the first three. And then from these two, we could take out a negative 29. So we'd be left with x minus 3, right? 87 divided by negative 29 is negative 3. Then we could take out an x minus 3, and we'd be left with 2x minus 29. Right? So taking this, rewriting it up here, basically 2x minus 3, 2x minus 29, and that has to equal 0. And then from here, easy to solve for x. So x minus 3 equals 0, so x can be 3, or 2x minus 29 equals 0. So that would be, x would be 29 over 2, which would be 14.5. So x equals 14.5 or x equals 3. Those are two possible solutions. Now what you have to do is you have to actually take these and test them with the word problem that you're dealing with. So we know that the length of the new patch of grass is 20 minus 2x. The width is 15 minus 2x. Well, if we plug in an x value of 3 here, then notice the length would be what? 20 minus 2 times 3, which would give us 14, and 15 minus 2 times 3, which would give us 9. So because we have a positive length, positive width, this x equals 3 works. But notice x equals 14.5. If we plug 14.5 for these x's here, we'll get negative values for the length and width. And that is impossible. You can't have negative values for length and width. So we know that this answer, 14.5, doesn't work for this word problem. So we would just ignore that. So the only answer that does work is this x equals 3. And that's actually the answer to the question. So the length of that uniform strip is 3 meters. And you can actually check your answer as well. So you could take 14 times 9, the length times the width, and what does that have to equal? It has to equal 126 meters squared, which is 42% of the original. So lots of ways to check your answer too. But this is 3 meters here. Another thing I want to point out is this doesn't always have to be a whole number. I could have made this question in a way where the final answer would be a decimal. It's just that this factored smoothly. That's why we got a nice whole number here. But a lot of times, maybe this won't factor smoothly. You'll have to throw it in a quadratic formula to get that decimal value. You could have also threw this in a quadratic formula at the beginning. You didn't have to factor, and you would have got these two answers as well. So, multiple ways to do it, but personally, I always like to check if I can factor, just because I feel like it makes the process a lot smoother. But sometimes you're dealing with pretty big numbers, so sometimes it's better to use the quadratic formula. Moving on to the second scenario, we're told that a pool measures 12 meters by 10 meters, and the deck around it has a uniform width and an area that is twice the pool's area. So, kind of a similar question. There's going to be a uniform deck around a rectangle, but the way we draw this is going to be a little different. So, notice here we're going to start with the pool. So this is 12 by 10 meters. And then we're told there's a deck around it that has a uniform width. So this is x. This here is x. X. And x. Let's make this look a little nicer here. Okay, so that's our diagram right there. So notice in this scenario, we drew this first, and then we drew the outer rectangle. Versus in the first scenario, we drew the outer rectangle, and then we drew the inner one, right? So it's a little bit different. The way we're going to set up the equations is going to be a little bit different as well. So just take notice of the difference between scenario 2 and scenario 1. Because you may run into both types of questions. So the deck around it has a uniform width and an area that is twice the pool's area. So what they mean is that this area here, the area of the deck, is twice the pool's area. So what is the pool's area? Well, it's 12 by 10. The pool is right there. Then the deck is around it. So it's 120 meters squared. So what's the deck's area going to be? Well, it's going to be twice the pool's area. So 120 meters squared times 2, which is 240 meters squared. So this shaded region has an area of 240 meters squared. Now, how can we create an expression where we can solve for x using either area, most likely this deck area here? How can we represent this, this shaded area here? Well, we could take the large area, the large rectangle, and we could subtract the small rectangle. How can we get an expression for the length of the large rectangle and the width over here? Well, in terms of the length, we know the length of the pool is 12. So if we take 12 and we add x, that would give us this length here. So it would be 12 plus 2x. That's going to be the area of this large rectangle here. Similarly, the width, I can actually write it over here, is going to be 10 plus x, so 10 plus 2x. Right? So this large length, 12 plus 2x, this large width, 10 plus 2x. So again, the deck's area we can represent as the large area being the pool and the deck, so the large rectangle minus the pool area. So what is the large area going to be? Well, the large area is going to be length, so 12 plus 2x, times the width, which is 10 plus 2x, And then notice we could sub in for the deck's area and the pool area. The deck area is 240 and the pool area is 120. So the large area minus the pool area is equal to the deck's area. And now notice that we have an equation where we can solve for x. So what I'm going to do is I'm going to FOIL this bracket out and I'm going to bring the 240 over. So we're going to have 0 left on the left side. 12 times 10 is 120. 12 times 2 is 24x. This is going to be 20x. This is going to be 4x squared. And minus 20 minus 240, that would give us minus 360, like that. And now let's collect some like terms. So we'd have 4x squared. 24x plus 20x, that would give us 44x. 120 minus 360, that would give us minus 240, like that. And now we have a quadratic equation that we could solve. So you could throw it in the quadratic formula. I'm going to try to factor it. So take out a 4. This would be what, 60? Like that. And then this will factor into x plus 15, x minus 4, like that. So from here we can tell the two answers are x can be negative 15 or x can be 4. X being, remember, the length of that deck, the uniform deck around the pool. So x equals negative 15, we can't have a negative length. So we would ignore that answer. And then x equals 4, that seems like it will work. So you can also check your answer here. So 12 plus 2 times 4 is 12 plus 8, which is 20. So this length here would be 20, and then 10 plus 2 times 4 would give us 18, like that. So 20 times 18, this large area here is 360, minus the pool's area of 120, that gives us the deck's area of 240, which is what we were supposed to get. So that there is the final answer. The width of that uniform deck here is 4 meters. Right? So notice how this scenario was a little bit different than the first scenario. So I actually want to compare the diagrams. So I'm going to keep this diagram here, and then I'm going to redraw the diagram from the first scenario. So the first scenario, we had the rectangle given, which was 20 by 15, and then we had to draw the smaller rectangle. So this was x, this was x, this was x, this was x. So that means this here was 20 minus 2x, and then this here was 15 minus 2x. So notice the difference between these two diagrams. Here we're given the measures of the smaller rectangle. So then the larger rectangle, we have to add 2x to both the length and the width to get the length and the width of the larger rectangle. Versus in the first scenario, we were given the measurements of the larger rectangle. So to get the measurements of the smaller rectangle, we had to subtract 2x and subtract 2x instead of adding. Right? So you can run into any of these situations. So you have to recognize, are you given the measurements for the smaller rectangle or the larger rectangle? It's pretty critical. And then they can word these questions differently as well. So notice that here we were told that the deck's area is twice the pool's area, but they may tell you that the area of the deck is a certain measurement. So they might give you the number. So you don't have to take 120 multiplied by 240. You could just plug that number in. Sometimes they'll tell you the area of the pool and the deck. So they won't just give you the deck's area, they'll give you that large area. So then you would just take this, multiply by that, equals that area. So they can give you different things. So best thing to do with these types of questions is to get as much practice as possible and recognize which kind of diagram you're going to be using.